Intermolecular forces are the forces that exist between molecules. Don't confuse these with intramolecular forces, which are the strong forces that keep a molecule together. Intra means inside, so these are the inside forces in a molecule. Inter means between, so these are the forces between molecules. To remember the difference between inter and intra, I always think of interstate. In every state, there is an interstate road that goes across more than one state, like Interstate 80 that runs from the Pacific Ocean in California to the Atlantic Ocean in New York. Intermolecular forces are weaker than intramolecular forces, but still very important. The two intermolecular forces we are talking about in this video include dipole-dipole and ion-dipole. A dipole is a molecule that has both positive and negative regions. Although we talk as though electrons distribute their time evenly among all atoms in a molecule, some elements have more affinity for the electrons than others, and they hang out around that atom more. We also talk about these molecules being polar. A polar molecule is a molecule with a slightly positive side and a slightly negative side. I always think about the north and south poles of the Earth to help me remember what a polar molecule is. A dipole-dipole force is when the positive side of a polar molecule attracts the negative side of another polar molecule. In order for this kind of bond to work, the molecules need to be very close to each other, like they are in a liquid. An ion-dipole force is just what its name says. It is a force between an ion and a dipole molecule. Remember that an ion is an atom that has gained or lost one or more electrons, and therefore has a negative or positive charge. A cation is an atom that has lost a valence electron, and therefore has more positive protons than negative electrons, so it is positively charged. An anion is an atom that has gained a valence electron and is negatively charged. So knowing that a dipole molecule has a slight charge on either side, and that ions have charges, either negative or positive, you can understand how these would bond together. Cations would be attracted to the negative side of a polar molecule, and anions would be attracted to the positive side. Simply put, a hydrogen bond is an attraction between a slightly positive hydrogen on one molecule and a slightly negative atom on another molecule. Hydrogen bonds are dipole-dipole forces. The large electronegativity difference between hydrogen atoms and several other atoms, such as fluorine, oxygen, and nitrogen, causes the bond between them to be polar. The other atoms have more affinity for the shared electrons, so they become slightly negatively charged, and hydrogen becomes slightly positively charged. Hydrogen atoms are small, so they can cozy up close to other atoms. This allows them to come very close to the slightly negatively charged, unshared electron pair of a nearby atom and create a bond with it. A hydrogen bond is usually represented